In section 4.4, we're looking at finding the area of triangles, and we have a couple different formulas. First of all, if we have a base and a height that are perpendicular to each other, then we know we can always find the area of that triangle by taking 1/2 times the base times the height. But if we're given a side angle side and we're not in a scenario where we have the base and the height that are perpendicular, but maybe we know side A is 8 centimeters and side B is 11 centimeters, and we know angle C is 25 degrees. So our given information is side angle side, where we have these two given sides and the included angle. In this scenario, we can set up using SOHCAHTOA and find the height, because we have this angle. Now, because we're looking at this being perpendicular, that just turned this side into our hypotenuse. And so we could say that the sine of our angle that we're given is going to be equal to this height over that side. Let's just call it side A for right now. It's opposite of angle A. Now if I multiply both sides by A, we find that H is equal to A times the sine of angle C. So if we're in a side angle side situation, we can always find the height by taking this side A times the sine of the angle. And that gives us our height. So if we know that we have 1/2 base times height, then we can find the area here by taking 1/2 times our base, which in this case is going to be side B, times our height, which we just found to be equal to A times the sine of C. So we have side A and side B. Here's side A being part of this to find our height, and then side B is being our base, and then sine times angle C is our included angle. This is the formula we end up with. So we have our two given sides and the included angle. So we have our two given sides and the included angle. So then from here, we plug in our information. So we have side A is 8, side B is 11, and our included angle, sine of angle C. And because we're multiplying all the way across here, it really doesn't make a difference what side we call A or what side we call B. We're just going to have our two sides that are part of this angle. And angle C is 25 degrees. So if we plug that into the calculator, we have 1/2 times side A, which was 8, times side B, which was 11, times the sine of angle C, which is 25 degrees. I need to be in degrees for my mode. And so we find that the area of that triangle is approximately 18.6. And of course, if we're talking area, then our label would have to be centimeters squared. So anytime we have a side angle side relationship, we can use this formula. We don't actually have to go through and find the height. We can just use this formula where we have our two given sides and the included angle. The other situation is if we have a side-side-side relationship. Now side-side-side means that we're given all three sides. So we'll say we have side A and side B and side C. Now what we need to first do is find a value for S. First step. Now to find that, S is going to be equal to 1/2 of A plus B plus C. And then for step 2, to find the area, we're going to take the square root of S times S minus A times S minus B times S minus C. And this is known as Heron's formula. So if we have a triangle where we're given all three sides, and we have 10, 11, and 12. Again, first we want to find S. S is going to be equal to 1/2 of, we add up all three sides, 10 plus 11 plus 12. And so here we find that S is 16.5. So then our next step, now that we have a value for S, we're going to find the area by taking the square root of, and we'll take the product. So we have S, 16.5. times that value 16.5 minus 10. So that would give us 6.5. And then we also have 16.5 minus 11. That gives us 5.5. And we have 16.5 minus 12. That gives us 4.5. So then we're going to find the product there. So we're going to take the square root and we can plug that entire thing into the calculator. So square root of 16.5 times 6.5 times 5.5 times 4.5. And we find that the area of that triangle is approximately 51.5 units squared. And there's two methods for finding the area of triangles.